Hello everyone, welcome to another video, and in this one we are talking about human in the loop. So human in the loop is a very basic or very popular design pattern when you are building your agentic workflow, which allows your agent or agentic workflow to wait for some time and get some human feedback or get some human input or clarification, whatever they need, and then resume back. So this can be used to build a much more powerful agents. One of the agents can be a reasoning agent, which at the time of start or basically while starting your agent or agentic workflow, you have no idea about what information they might need, or like the agent can like reason or think for some time, do some deep thinking and then come up with a response saying that, hey, I need these set of information from the user in order to complete the workflow. So in those cases we should be able to interrupt the workflow at that point of time, collect those required information from the user or from the human, and then resume back with the collected information so that the agent or our agent which we have built here has everything what we need. So that is the high level idea on the human in the loop, and we perform human in the loop by interrupting our agentic workflow. So here you can see this design. This is one of the high level design of what we are trying to implement here. And let me zoom it up a bit. Okay, so this is the design. What we are doing is that the user on the left side, the user is sending a query to the agent. Now this kick starts the workflow. Now once you have the query, we are giving the query in a way that agent has to get something from the human in order to complete the workflow. Now we'll give a query something like, hey, can you ask the user about the location where they are, and then for that particular location can you get the weather information. That can be one suitable query which we can send to the agent. Now once this query goes to the agent will provide a ask human tool which the agent can call, which and then the ask human tool will gonna interrupt the workflow and will ask or intimate the human to provide the information. So the idea is, if an agent thinks that they will need some clarifying question to complete the workflow, they can call the ask human tool, and the ask human tool will gonna query or will gonna ask that question to the human while interrupting the workflow and get the response and get the answer from the human, and it will give the answer back to the agent and the workflow will resume. So in our query, what will happen is that the user will ask the agent that, hey, can you ask the human about the location where they are currently in, and then can you find the weather information about the location. So for that the agent will think and will come up that, hey, I think that in order to get the weather location, I need to get the information about the user's current location. So here the agent will understand that they have to ask human or ask the user about their current location. So the agent will go ahead and will call the ask human tool with the relifying or with the clarifying question. So in this case the question will be, where are you currently located in? So the ask human tool will gonna pass that question to the, will gonna basically first interrupt the workflow and pass that question to the human that, hey, which location are you currently located in? We'll get this question from our agent, and then we'll gonna respond with the answer, and I'll also show you that how you can then resume the workflow with the while responding with an answer. So what will happen is that the ask human tool will ask the question about the human location, and the user will give their location saying that, hey, I am currently located in Delhi, India, and this answer will be given back to the human tool, which will gonna propagate this answer back to the agent. Then the agent will have the answer that, okay, the current location of the user is Delhi, India. Then the agent will gonna perform the web search tool where they'll give the location and they'll gonna search for the current weather condition for that particular location. So the web search will happen, and as a search result the current weather condition of that location will be returned, and this web search tool will return this information back to the agent, and the agent will return back the response to the user. So this will perform, so by building this will perform a basic POC where we'll see that how you can interrupt your workflow in the middle in the case of any clarifying question if an agent wants to ask, and then how you can collect the answer from the human for that question, and then how will you resume your workflow from there. Now this is a very basic example. Once you learn human in the loop, you can use that to build multiple powerful agent. One of the examples can be a deep research agent where you give the problem statement to the agent, and then the agent can break down that problem statement into multiple smaller problem statements or goals to achieve. And if in that case they come up with a goal for which they want to get more information from the human, they can interrupt the workflow in the middle, get their question being answered from the user, get the relevant answer, and then use that or continue their deep research from there. So you can use these basically use this concept of human in the loop to build very strong, powerful, deep reasoning agents. So now let's quickly talk about the formal definition here. And the formal definition states that human in the loop HIL interactions are crucial for agentic systems. Waiting for human input is a common HIL interaction pattern, allowing the agent to ask user clarifying question and await input before proceeding. So HIL, a short form for human in the loop, and it is a very common interaction pattern which we discussed earlier as well. Now the important thing to note here is we are building this proof of concept on human in the loop using the LangChain framework. And if you are keeping up with this AI Engineering 101 playlist, you must be aware of that whatever previous episodes or whatever previous POCs and workflows we have built in the past episodes, all of them are done on, or all of them are built on top of LangChain and LangGraph. And this will also be done in LangChain. And we'll first understand how the LangChain or the LangGraph framework provides us the capability of human in the loop. So in order to interrupt or in order to stop your workflow execution in the middle, in order to collect the inputs from the user, this is done using the interrupt function in LangGraph. And interrupt use LangGraph's persistent layer, which saves the graph state to indefinitely pause graph execution until you resume. So LangGraph has the capability of saving, or basically they have a persistent layer which allows us to save the particular state of the graph execution in the middle and pause it, and then once we have the information which we require, we can resume the graph execution from that particular point. So they leverage the concept of thread and checkpoints in order to achieve that. Now this is possible because LangGraph checkpoints the graph state after each step, which allows the system to persist execution context and later resume the workflow continuing from where it left off. Now you must have played video games, right? And in the video games, this is a very basic concept of checkpoints and autosave or save points, where you can save till where you have played, and then when you can like go back and maybe day or two later you can come back and you can start from that particular point. You can think of this concept similar to that, where you are executing your workflow, and if at some point of time you need some inputs from the human, you can stop the execution at that particular point of time, and the checkpoints will gonna save the graph state at that particular point, and then you can answer, or basically the human can provide the information or the answer which the workflow needs. And once you have the information, the execution can be resumed from that particular point, and that is possible using the concept of checkpoints and threads. Now to talk about the persistence layer, I can maybe make another separate video on it, that how LangGraph persistence layer works and how what is the concept of threads and checkpoints and how you can leverage them. I have made a very small, or I have made a very decent video on this concept previously as well. So if you go to the one of the episodes where I talk about debugging the agentic workflow, I have talked about the concept of threads in the LangGraph workflow. But yeah, we can work on basically I can work on making another video on the persistence layer, but for now this should be enough for doing the POC. You should be aware of the concept of checkpoints and a thread, which I have like covered in a decent amount, and that should be all right. And the main thing is the interrupt function, which we will use to interrupt the execution flow at a particular point of time. And this will get more clearer when we'll hop onto the POC and we'll hop onto the code walkthrough on how we build these interruptions, or how we build this human in the loop concept from scratch, right? So this is what we want to do, and we'll be using tools here as usual. Will like basically the ask human function which will interrupt the workflow execution will be provided to the large language model as a tool, so that the large language model can call it whenever they want, depending upon the need, right? And yeah, if you like, you'll be able to understand more once we go on to the code walkthrough. So let's do that quickly. So now we are on the code walkthrough, and I am in my AI Engineering 101 repo. Now, again, if you are keeping up with this playlist, you must be aware that along with building the playlist on YouTube, we are also building the source code for this playlist, and the source code is present on GitHub in my repo, or basically when you go to my profile, you can find my AI Engineering 101 repo, which has the collection of all the videos which is present in this playlist, or basically which has the collection of all the source code which is talked in the video present in this playlist. Now this is how the um, source code looks like. It basically, at the highest level, it has all the episodes which we have discussed: corrective rag, debugging workflow, few shot prompting, and a lot of things. Currently what we are discussing is human in the loop. So if we go into the human in the loop, we'll find the POC code here, and this is a notebook. So what we'll do is that we're gonna execute the cells one by one, and we'll understand what is happening here. So let me quickly collapse this one, and this is the notebook here. The first thing we always do in all the episodes in the code walkthrough, as usual, is to import the libraries. So these libraries are open source, so shouldn't cost any money, and you can import this basically. You just have to pre-install these libraries using the pip install command, but apart from that, everything should be all right. So I can run this one, and this will be imported. After that, I can define my tools. Now the two tools which I want to define is the search tool and the ask human tool, which we showcased in the high level diagram previously. There were two tools which the agent has access to. The first one is the search tool. Now the documentation says call to get a weather at a location. Now this the agent can call this tool if they want to find the weather of a particular location. Now the interesting thing to note is, in order to call this, they should have the location in place, right? They have to provide the location as a parameter to call this particular tool. And then once they have the location, we can execute this query with weather in and the location provided. And then we can perform a web search, and we can get the response which will have the weather condition of that particular location. And then we can return this response back to the user, or back to the agent, which will indirectly return it back to the user. In order to perform web search, we are using Tably Search. Tably Search is again an open source, or basically it's a software product which allows large language model to call web search or interact with the web searches, so that like they can expand their knowledge base, and that's what we are doing. You can go to the Tably website, and you can create your account. You will get an API key, and I guess for a month you can make around 50 to 100 calls to this API. So that should be more than enough if you are trying to do a POC where you involve web search in your agentic workflows. So that's what I am doing here. I have a free I haven't paid any money for this. I have an API key for my account here, which allows me to perform 50 to 70 web searches using models. So this is the web Tably search which I have initialized. This takes in the query, and it takes some configuration as well. The max results, I'm saying it should be 1, because I only want the 1 result, because I don't want more information. I just want the top result, which includes the weather condition. I want the answer to be included. Along with that, once the tool is built, I can invoke this with my query. Second tool is ask human tool. This has a description: ask the human a question. So this is an interesting tool, which what it does is that it interrupts the workflow. Now this is the heart of the human in the loop. The thing is, whenever a large language model thinks that they want to ask some question or clarifying question from the human or the user, they can call this tool. They'll call this tool with the question, and this tool will have the responsibility of interrupting the workflow, getting the response back, and resuming it, right? This tool does that. So once it gets the human response, we can resume the workflow, and the workflow will be resumed from here. So once the workflow resumes, it will gonna return the human response back to our agent. Now these are the two tools which we need to understand very carefully. After that, we have the basic build model method, which builds the large language model for us. What we are using here is an OpenAI model, GPT-4 model here, and we are binding the tools which we defined above. So the search tool and the ask human tool which we defined, we are binding these two tools with the model so that our model is basically aware of these two tools, and if they want they can call it with the correct arguments. After that, we have the run agent. This is the node. This is the one and only node in our workflow. But what it will do is that it will gonna invoke the model with the query. And if the query states a need of a human answer or a human response, then it will gonna return with a tool call. And if the model thinks that we need to wait or ask human some question, then the ask human tool call will be present, and then what we will do is that we'll gonna call the ask human tool with the correct arguments provided by the model, and then we can get the human response. So in our case, we'll get the location for which we want to query the weather information. Once we have this response, we can invoke the search tool with the location provided by the user. The search tool will gonna defined above here will gonna search for the weather information of the location which we provided and will return the response. Now once we get back the web search response, we can save that in our shared state. If there is no tool call, we can directly get the agent response. Whatever agent responded, we can store that in the agent response and we can return the state. So there are two conditions. First, where a agent will think they want to perform a tool call, then we will gonna execute this one. If the agent thinks that they don't want to perform a tool call, they just have a basic response, we can capture that response in our shared state and we can return the shared state. Now you must be aware of, if you are keeping up with this playlist again, that in the LangGraph we have the concept of shared state where all the information is preserved during the execution and that is at the end returned to the user. That's why we are putting all the information in our shared state and we are returning it back to the user. After that, we're gonna build the workflow with the above function and the tools which we described. So the first thing is building the shared state. Our shared state looks like this. The name is human in loop state. What it has a query, it has an agent response, it has a web search response. Now the query is the query which we are sending while executing the workflow. It's a string. Agent response is an AI message. If the agent returns some AI message, we'll capture that in the agent response. Web search response is a dictionary which we are getting back from the search response. So it can be a dictionary or we can have it as string as well. So it can be both. And if the search response in the form of string, will capture that as well. After that, we can define the new graph. So the workflow looks something like this. We start the workflow by defining the state graph with our shared state, and then we build the workflow. The one and only node, as I explained earlier, is the run agent node. This is the one. After that, we set up the edges here. Once we have added the node, the edges is very simple. The start node will point to the run agent and the run agent will point to the end node. And this is what the workflow will be. After that, as I mentioned earlier, we will need to have set up the checkpoint, and in order to set the checkpoint, we need to set the memory because we want to store the current execution or the current checkpoint in the memory. So we'll define the memory here, and after that we're gonna compile the workflow with our checkpoint, and then we can start the execution. In order to start the execution, we need to build a configurable or build a config with the thread ID, and thread basically handles the workflow execution, and if we are saving any checkpoints, that checkpoint is saved against this particular thread ID, right? So we build the configuration, we pass on the configuration along with our query to the workflow, and then we try to get back the response from it. So this is how the current code base looks like. We can define each and everything one by one. So we already defined the libraries. Let's define the tools. Okay, so we have defined the tool here. Now let's define all the functions. The functions are also defined. Now we can set the workflow. So this is how the workflow looks like, and we can run this. So now we have set the workflow. After that, we can set up the memory and we can set up the check pointer so that we have the capability of saving the state of a workflow at any point of time. And we also, I'm also displaying how the workflow will looks like once it is compiled. So this is how the workflow looks like. As I mentioned, we only have a single node, that is the run agent node. We start and we go to the run agent executes, and then we end the workflow. Okay, after that we're gonna run this. So in order to run this, I'll gonna basically load my environment variables, and I'll set up the configurable with the thread ID. I am choosing the thread ID to be 2 here. You can choose to be any number, but you should be aware that if you are executing multiple threads, the ID should be distinct. We invoke our workflow with the shared state. That shared state was defined here, human in the loop state, and human in loop state initially will have query. Rest of the thing will be added once as the workflow execution continues. And the query looks like this: ask the user where they are, then look up the weather there. So once the LLM gets this query, they're gonna quickly understand that in order to perform this, or basically in order to answer this query, they will need to have, or basically they'll need to ask the user about their location. And once they figure out that they will need to ask user something, they will call the ask human tool with their preferred question, and that ask human tool will gonna interrupt the workflow at that time with the question, and it will wait for us to answer, and then it will gonna resume the workflow. Now let's see that in action. I'm gonna run this one, and the agent is running. After that, it is saying asking human because the ask human tool is called, and the query is ask the user where they are, look up the weather there. This is the query which we sent, and the interrupt happened with the value where are you currently located. So the agent came back with the question saying where are you currently located. Now we have to answer it and we have to resume the workflow so that our workflow continues. So this is how you resume it. It's a very simple command. In the same app which you have compiled, you need to run the command with the resume key, and in the resume key you will put your answer so that the workflow which was currently paused can be resumed, and we can send back our answer about the location here, and then the workflow will gonna get the location from us and it will gonna query the weather condition there. Okay. Currently our workflow is in a paused state, and this is possible because of this checkpointer memory. Right? We are storing the current execution in the checkpointer. Now I can resume the workflow. When I'll run this, it will gonna resume with the location which we provided, that is Lucknow, India, and it will gonna try to find the weather condition there. Again, the agent is running. It got back the response, performing a web search for weather in Lucknow, India. Okay, so now it got back the response and it performed the web search. Interesting thing is, even we resumed, all the previous state or all the things which happened previously also got printed out, and then it resumed with the current information, that is weather in Lucknow, India. And as of today, Lucknow, India is experiencing mist with a temperature of 28.2 degrees Celsius. Winds are from southeast to 9.8 miles per hour. The humidity is high at 89%. Now this is okay. Now what you can do is that you can, if you want, you can change the location. So I can maybe start the workflow execution again, and I can experiment with some other location and it will work. That is basically the idea here. So let me do that. I'll gonna refresh the memory here, and I'll again execute it, and it will again run the agent. It will again ask the same question, where are you currently located? But at this time I can maybe say something else. Maybe I can say San Francisco, California. So I can provide this location, and I can ask the agent to give me the weather for this one, and this will gonna run, and it will gonna perform a search for weather in San Francisco, California, and this is the weather. On August 25, 2025, San Francisco, California will be partly cloudy with a temperature of 16 degrees Celsius. The wind will blow from west at 6.9 miles per hour. Humidity is high at 87%. Right. This is what the weather currently looks like in SF. Now you can build a lot of, so this was just a POC. You can build a lot of more powerful agents using human in the loop, and I'll try to cover maybe a deep reasoning agent, which we can try to build using the human in the loop in the upcoming video. So stay tuned for that. But yeah, this is the entire code walkthrough for the current human in the loop session. So this was end on building human in the loop or understanding how we can interrupt our agentic workflow, wait for the human response, and again resume it from that particular point of time. Now, this was it, and if you found this insightful, do like this video, subscribe to this channel, and share it with others who can be benefited from this. We are building the AI Engineering 101 playlist, where basically we try to put out 1 or 2 videos per week on AI engineering about maybe a proof of concept or maybe building a workflow from scratch. But for any video we do, we try to understand how you can build that particular concept or workflow from scratch. We do code walkthrough, and all the code snippet or all the source code which is discussed here in this video is present in my AI engineering repository on GitHub, to which the link is present in the description of the video. So stay tuned for the 4 future videos, and I'll meet you in the next video.